I'm working on a C++ audio plugin that uses a machine learning model. It was very hard for me to just find the libraries and stuff that I needed to put together in order to get it to work. So if you're trying to use an ML model in a JUCE audio plugin and you're scratching your head about how to do it, this video is for you. I'm going to show you a simple example of a pitch detection plugin that uses a machine learning model and provide you with resources to get it working on macOS and Windows. So the first thing to do is to just create a new project in the producer. I always include the DSP and OSC modules, although I'm not sure if OSC is necessary. I don't know. And then the producer will auto-generate a bunch of files that the project will use, like all of that. But from this point on, we can actually ditch the producer and switch to a different compiler, CMake. So you can make a text file called CMake lists, which is a set of instructions for the compiler, basically. And I already have one ready, and it should look like this. So it's basically just a set of instructions. If you're on a newer Mac, you should change this for your hardware architecture. Make sure you set the correct path to your JUCE repository. You can put your own custom names and stuff here. And we've got to make a pitch detector.h and .cpp file. So I'm going to do that now. And for now, these can just be blank. We're going to be adding to those later. We'll also need a folder called resources, in which we'll include the machine learning model for pitch detection and this background image I made. And then the remaining stuff in the CMake lists file is just to do with the correct paths to the ONNX runtime directory and just linking everything. So if you're wondering where to get the machine learning model and the ONNX runtime, I'm going to include links in the description of this video. But it's also worth mentioning how I found them after weeks, if not months, of effort. So I'll pull up the web pages. It's important to get a version of ONNX runtime that has been built statically, because JUCE plugins don't like building using dynamic libraries. And I'm not entirely sure how that works, but it just doesn't build when you use the dynamic official release made by ONNX runtime. But luckily, some smart people have made workarounds to this. So this repository has good downloads for ONNX runtime static builds that work on Windows. And I tried their builds on macOS, but for some reason I keep bumping into this error, with some sort of core ML error. I don't know exactly what that is. So then I also found this repository, which has static builds for ONNX runtime that work on macOS, and I'm using one of these now. The pitch detection model I'm using is called CREPE. There are many ways of doing pitch detection, but this one specifically is a machine learning model, and somebody converted it to ONNX format, which is necessary in order to get it to run in C++. So I'll add links to these repositories, but once you've got those downloaded and linked to their file path, you can open a new terminal and go to your project directory. And you should make a new folder in it called cmake build. And then if you're on Windows, you can just run this command and it'll automatically generate a Visual Studio solution, so you can open it as a project in Visual Studio. On macOS, you can do a similar thing with Xcode, but you have to add this to the command. Oh, sorry, I have to switch into the cmake build folder. And this usually takes a while. Okay, then the next command you can run to build it for the first time looks like that. And you can build it as either debug or release. Okay, once that's done, you can close the terminal. And it should have automatically copied your builds to your plugins folder, which is where your DAW like FL Studio will search for it. So the next step is to open it up in Xcode. From here we'll actually be able to edit the code of the plugin and build it. So we can open up the header files and the C++ files. And we can also set up our build settings to get it to automatically open in our DAW. I'm just going to be building the AU for now. I think it automatically builds VST3 and audio unit. But you can go and edit the scheme and then set it to open with FL Studio or whichever DAW you use. So now if we click the build button, it should actually open your DAW once it's done building. This always takes a while. Once your DAW opens, you can navigate to your plugins. And there it is, there's our program. Right now it's just a hello world, but we can begin adding to it. So I think the first thing I'm going to do is set up the UI, then we're going to populate the pitch detector logic, and finally implement it in the plugin processor, which is where it'll actually process input audio, detect its pitch, and then give it to the UI to display. Okay, so I filled in these files. The main thing you want to make sure is that when you add this line to include the ONNX Runtime C++ API, if you can build your project after including this line, then chances are everything else is going to work. I used Grok to generate the rest of this stuff. I presume it draws upon documentation that I just didn't want to read, but suffice it to say, all of this functionality likely exists in the documentation of CREPE and ONNX Runtime. One thing that I did have to change, which is kind of strange, is that there was this distortion in the detected pitches that I just had to account for by multiplying it by this coefficient. Now in the plugin processor, I added some functions to get the status of the pitch detection model to see if it's ready, as well as functions to get the detected frequency and confidence. It's useful to run ML models on a background thread asynchronously, because if you run them on the main audio thread, it'll freeze up the audio, because sometimes ML models are too slow compared to real-time audio processing. I have this old relic that I actually don't need. In the plugin processor.cpp file, you just gotta make sure to add the pitch detector here at the top, and then get it to start in the constructor, start the thread, and in the destructor, when the program closes, give it a second to stop. And then in the process block, luckily all you have to do for this model to get it to work is just to say if it's active, then process the audio on the pitch thread. There are these functions as well in the pitch detection thread. I'll put this code up on GitHub, so if anyone wants, you can have a look at it. And finally, there are the get current frequency and get current confidence functions, which are then used by the editor to continuously update the display with the latest detected pitch and confidence. So we can run this and test it. Okay, and you can see our program loads, which is great. So when it's silent, it displays a frequency, a random frequency, but the confidence is low. We can play a sine wave through it, and now it detects 440, and I have a spectrometer here so you can just see that it is in fact 440, around 440 Hertz. So this is a proof of concept that you can run machine learning inference in a real-time audio plugin in C++. This stuff was tricky for me to set up, so I hope if somebody else has this problem, I hope this video helps.